We are officially recording. Welcome to Math 1040, all you nerds. Let's have fun. So anyhow, uh, things that I know you're curious about, like how will you be graded, right? So there will be weekly written homework that you can either submit. I guess they probably don't want you to submit it to me personally. They'll probably want you to upload it to Canvas. So you'll have weekly written homework uploaded to Canvas. That's how some of your grade's going to come. The other part of your grade will be weekly homework on Canvas. So that means like you'll do something and you'll answer like a couple multiple choice questions or something like that. It'll be very low stakes. It's not going to be hard. It'll be very simple stuff. Well, maybe not simple, but it won't be hours worth of work. And then the big thing you'll be worried about is 2 exams. So, and the breakdown of how all this is going to be is going to be on Canvas. You'll see it how it's broken down. But your written homework and exams are pretty much going to be worth the same weight. So it's not like you're going to flunk if you do bad on a test necessarily. Does that make sense? So they'll carry very much the same type of weight. Does anybody have a comment or a question? I keep saying that. You guys just look at me. Don't do that on a job interview. When they ask you if you have a question, you make one up. Even if you don't have. Lesson 1 from O'Grady. Now, I'm going to walk over here. Bye. I feel like I got to walk. No question? Anytime you ask someone to ask a question, count to 10. See if you figured it out. You still have it. You guys are flunking the first test. Tyler, you got to learn these things. This ain't your first rodeo either, is it? No, you got to. It's like your 4th. Yeah. Goodness gracious. Yeah. What a time. All right. So, okay. So what's this class about? It could be about a lot of things. I probably don't teach this class in the same way that most people teach it. A fascinating thing about this class is that, at least from the perspective of the mathematician, that's me, is much of understanding statistics and learning statistics is dependent on how much probability that you understand. And we're gonna emphasize that point in a second, and sort of set the scene for the semester. But the problem is mathematics, the probability, the branch of math that is probability, is even though we teach it at this level where we only expect that you know some algebra, if you really want to fully understand probability, it requires that you understand calculus. Now, that's sort of like a counterintuitive statement because most of you haven't had calculus. At least you're not required to have had it to sit in this class, right? And that's okay. We're going to try to work around that, but it makes it a little difficult to sort of emphasize some of these technical points that we're going to talk about. So the way I would like to get this going is I like to sort of motivate the course with some questions. And particularly, these are kind of questions they're more inspired to get you to think about things that you say and do, and you probably, if you give it good thought, have no idea what you're actually saying. Now, that's not to be offensive to you. Let me give you a good point. So if I said to you right now, define boiling point. So here, if I said, take out a sheet of paper and tell me what the definition of boiling point of water is, you know what you guys would all write down? Every one of you. How do I know? Because I've seen this before. You'll say the temperature at which water boils. And I'll be like, nope, obviously, but that ain't the definition. How can you define something using the word you're trying to define? Or if I say define area, you'll say the area that something takes up. And I'll say, well, how do you define a word using the word you're asked to define? See, mathematics in probability is a branch of mathematics. It falls on a, is about making these things precise. Not just those two examples, because boiling point ain't one of them in this class. An area is important here, but it's not, you know, the area question is really answered in calculus. But what probability is about making certain things precise so that we can have useful information to absorb and judge other information. So that seems like a loaded couple sentences. Let me elaborate with a couple things. So here's some things to think about. And we'll use a fancy wealth test word, because I know you all scored 1,500 on your SATs. Things to ponder. Number one, what does 30% chance of rain mean? I mean, this is something you probably all thought about at numerous. I mean, I don't know. If you're anything like me, I check the weather app on my phone all the time. What am I going to do today? Am I golfing? Am I going swimming? Am I working on my tan? Am I sitting in the house Netflix? Right? I look at the weather, and there'll usually be a little picture of the sun. That's kind of obvious, and then maybe some clouds, and then it'll have a number like a high and a low, and then it'll have a percentage that tells you that it might rain. But what does this mean? If I asked you to define what this sentence means or explain it to someone, could you explain it? Think about that. And then if you start thinking about it, then you're going to realize, no, you can't. Because it could mean lots of different things, right? It's very ambiguous. What's that?
Usually it's not going to rain unless you have a going on.
This is true. This is true. Although it is funny because Seattle gets this bad rap as like a rainy city, but it rains more in Pittsburgh than it does in Seattle. Although we've had one hell of a summer. I don't know if you've been paying attention, dude. My grass is brown. It's been like 85 and sunny since June. Can't even go out to a bar or anything now. The Roni. That's what we should do. We shouldn't make light of it. We should have the first question. Who believes the Roni's a hoax? And who believes it's real? We'll find out which political aisle you guys all lay on, right? Those will be good. Get everybody riled up early. I kid, of course. But no, so your point is actually a funny one, because that literally is a reasonable answer to what does this mean? Because every one of you can write something down and it could make logical sense, but it can also mean utter nonsense depending on what you've written. Give you an example. A better way of thinking about this is, how are you supposed to interpret this? Does the Weather Channel tell you how to interpret this? Does Jeff Brazilla say before do you guys even watch the news? Probably not. Like, people your age don't watch the news, do you? You just look at your, I mean, I'm just curious. Like, the weather in the news in the morning, it's just the weather and traffic every 30 seconds, right? And they don't tell you what this means. They just say 30% chance of rain, scattered showers. Well, what does that mean? Does that mean 30% of the viewing area will get wet all day, or just a portion of the day? What does that mean? Now, the good news is you might not be able to answer that right now, and that's okay, because one of the things we're going to try to get you to learn in this class is how to interpret this in a reasonable and logical way. Does that make sense? There's another problem I always find interesting. So we'll change colors. It's always good. We'll go with red. We'll go with the Bloods and the Crips. We'll do blue next. All right, so so let's say you're offered a job with a 5-person company. And their pitch to get you to take the job is this. Average salary is, let's say, $2 million. So let's assume we're in a world when you get out of school and you have lots of job offers. And of course, like any good capitalist person, you want the highest paying job, right? We all do. We all want the dinero. So what does your intuition tell you? There's 5 people that work at a company. The boss says, hey man, on average, we make $2 million a year here. Does that necessarily mean you're going to get paid a lot of money? Should you take the job? Bless you. So these are things I want you to think about. I'm not saying there's a right or a wrong answer. These are questions that you should reflect on. Think about it. I mean, maybe do a Google search at some outrageous company that's not maybe 5 people, like Amazon. What's the average salary of an Amazon employee? And is that a good characteristic of what most people at Amazon make? I don't know. That's what you have to ask yourself. I mean, imagine you have a 5-person company and the CEO makes $5 million a year. What are the other 4 people making if the average is $2 million? What if the CEO makes $15 million a year? What's everybody else making? So we use words like average all the time to try to get information about things, but we don't always use it in the correct context. I can develop a scenario, and you probably could too, where your salary is really good here, or your salary can be very bad. See, one of the problems, especially in our digital age, where we have all this information at our fingertips all the time, you know, Google and Twitter, and you know, everywhere you go, you put a card in and they track everything you do, and cameras are watching you, how you shop. They're collecting all this information about you, right? And of course, their argument is they're doing it to better serve you. I mean, you log on to the internet, it knows what you want before you know what you want, right? You're talking about something with your friends, your phone listens, you open up Facebook or Google, and then the first ad you see is what the hell you were talking about 30 seconds ago. But in this world of all this instant information and all this data and all these numbers, we have to be able to interpret it properly. So I was listening to this nerd podcast on my way in, and they made this great example about how we misuse numbers all the time, and how most of us don't really put context on things. Particularly, and now's a good time to really imagine that with all the back and forth battling with the COVID-19. But you know, if there's not context given to things, what kind of sense are we to make of it? If the only context I get about this job is this mean average salary, I guess I should finish this. What does that mean? Does that mean it's a good job based on salary alone? And again, we're ignoring right now things like quality of life and where you're going to move, but we're just saying numbers. Does anybody have a question, comment? Let's see if anybody's chatting. Is there no chatting? Oh, someone's in the waiting room. I'm sorry. Abby, I'm sorry. I didn't know you were in the waiting room. Forgive me. We will refund you $23.46 for time wasted. Which schools did that? I apologize, Abby. I'm sorry. You can fire me later. Okay, so again, these are things that I'm asking you to ponder, not just right now, but maybe later. Because whether you want to think about these or not, there are people in the real world who have to analyze questions like this, and their decisions on them will affect your life. When you go to apply for a loan to buy a car or a house, someone's going to ask, are you worthy of that? They're going to put your name and your information in a computer, and then there's going to be an algorithm that determines, hey, there is a 42% chance that Tyler will pay off this loan. And then some bank has to they want to take that risk. What does that mean to them that there's a 42% chance? Or, oh, you're 19 years old. There is blah, blah, blah chance you'll get in a car accident and need to use your insurance. What insurance premium should we give you? Does anybody have a question about this? Oh my God, my stupid phone keeps ringing. I keep getting text messages and phone calls from Biden and Trump. How do they get my number? Like, how do you even know who I am? Although Biden thinks I'm Kathy. So maybe someone had Kathy was my phone number years ago. I don't know. All right. Let's move on. Let's look at another one, sort of question that we often might not interpret properly. So how many times would you expect to have to flip a fair coin before you got 5 heads in a row? Now, it's possible that you flip it 5 times and you get heads the first 5 times, but how likely is that? Now, you might be sitting there saying, I don't care, it's stupid coin flips, who cares, right? But this is not just a stupid coin flip. This is a simplified version of real-world things, the decisions that people have to make. If I'm Nationwide Insurance, this kind of question interests me. Because if I have too many bad things happen in a row, I'm out of money. If I am a bank and I own mortgages like in 2006, 7, and 8, and too many people stop paying their mortgages, I'm out of money. Then the stock market collapses. Of course, you guys are too young to remember all that. It wasn't good. So studying things like runs of heads in a coin toss can be very useful for helping us as humans understand more complicated things, like how many accidents do we expect in a certain plant where they manufacture something? Or say I don't worry about accidents. Say I manufacture cars. How many defective parts do I expect? If I'm Honda and every car I send out, 6 of them out of 10 have defective parts, I'm going to be in trouble. So what we would like to be able to analyze a question like this. Anybody have a question? Comment? How would you even begin to study this? Yeah.
I was thinking, 5 links you want to try to look for it, 50% chance of getting it fail. So I was thinking at least like 10 times.
Well, you would imagine that that's one way to analyze it, but you might ask, can I be more precise? So maybe using a good problem-solving strategy, instead of answering this question, simplify it. Say, okay, how many flips would I expect to have to make until I get 2 heads in? Clearly, you need at least 2 flips, right? But you don't expect that to happen often, right? It could, but you don't expect it. Maybe 3. So these kind of questions, we're going to spend a lot of time this semester studying coin games like this and rolling dice. And the reason that we're going to study these games is because they're very simplified versions of real life things. Success, failure, life, death. Pay your loan, default on your loan. Does that make sense? There's lots of things in this world that come down to success and failure, so we're going to study those kinds of things in the simplest version possible. That is coin flipping. Now you might say, okay, well, what does that have to do with statistics? Well, it has everything. Look at our very first thing we wrote. What does 30% chance of rain mean? If you don't understand what 30% means, how can you put any context to that sentence? And if you don't understand the statement 30% chance of, how do you put context to things? So here's another way to think about it that might be useful for you to ponder. And that is, what is statistics? Now, of course, you're going to say, well, you're the professor and it's this class. You're the teacher, so tell us. Well, that's something you could easily Google, and everything you find is going to be the collection and analyzing of data, right? But what's data? How do you collect it? How do you know that you're analyzing meaningful data? Take a simple experiment. If I said we want to know what's the average home price in, say, the Pittsburgh area? How much does it cost to purchase a home in the Pittsburgh area, on average? Whatever that means right now. How would you go about trying to answer that question? Now, don't say I'd go Google it. Well, yeah, someone else maybe has tried to answer that already, and you could find data. I'm saying, how would you do it on your own? Are there any mistakes you could make in the process? Surely you're not going to go look at every single house in, say, Allegheny County's price, because that would probably take forever. It'd be too hard. Do you just take 20 houses? Do you take 200? Where do you take them from to get some sort of realistic notion of it? If you go to the wrong neighborhood, you might get way lower, or if you go to another neighborhood, you might get way higher, right? So these are questions I really want you to think about. And when you're thinking about them, I want you to also ponder this. So this is the O'Grady definition. It's the collection let me not say the collection. So let me rephrase that, because that sounds funny. So I'm going to write it like this: collecting and analyzing data. And more importantly, to properly analyze analyze data, we need a mathematical tool. And what is that mathematical tool? It's probability theory. So maybe I'll be even more clear: to properly attempt to analyze. So let's cover all our blind spots here. Let's not misspeak at all. So if we want to properly attempt to analyze data, whatever data is, we haven't even defined that yet, right? We need a mathematical tool. Is that clear, what I'm saying here? Now, you don't have to believe me, but this is the way the scientific world works, at least the ones that aren't knuckleheads. And so this is how we're going to teach it. And hence, that's why classes and introduction in a course like this is called probability and statistics. I mean, I could send you to the internet and say, go collect data. And I'm going to do that. And the point is, if I just tell you to collect data, if you don't have tools to sort of study it or analyze it, and then you don't have theory to try to make sense of it, then what good is collecting data? I mean, I like to use sports analogies all the time. You know, if I'm thinking about basketball, one way we track a player's effectiveness might be something like, okay, his free throw percentage or her free throw percentage. Well, if I just tell you someone made, 87% of their free throws without any context, that doesn't mean much. How do I know how many times they shot the ball? They only shot the ball 4 times, that 87% doesn't mean much. However, if they've shot over 400, then 87% is much more indicative of what they're offering. Does that make sense? Similar in baseball. If someone says they have a 500 average, we'd be like, oh my God, that's insane. Well, how do we know they've only batted twice and maybe they got a hit once and struck out the other time? Sports, and I use sports because it's something that I pay attention to, and I don't know, maybe some of you do, but it's a great example of how data is collected. And what's even more interesting is how over the years, how technology has changed and how those involved in sports have changed how they analyze data. What stats are actually important? So again, I started this off a couple slides ago, if I hop back, by saying things to ponder. These are things that in your time, these 4 questions are what if you want to get a learning experience out of this, if you want something useful, these are what you got to do. You got to think about these. All right, does anybody have a question? One of these days, you guys will say yes. And I'll be my heart will sink. It'll be like I fall in love all over it. My kid had a funny, philosophical thing yesterday. She goes, did I have a great, 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 great grandfather? And we're like, yes. She goes, well, if he's dead, how did I have him, right? So like I said, it's a great question. I don't know. How do you answer that to a 5-year-old? It's similar to like me I'm up here spewing to you guys, and you're probably like, what is he talking about? Life and death, heads and tails, pay a loan, don't pay a loan. Those kind of things. Did any of you ever try to get a credit card and they said no to you? Anybody? You can say, you don't have to admit it. I just thought, when I was your age, it was real easy to get credit cards. They would just give them away. They'd be waiting at the college. You'd sign your name. They'd give you a T-shirt, and a week later, you got a Discover card in the mail for like $3,000, and you just spend it all. But now it's a lot harder. They actually run your credit, and then they say to you, well, you don't make any money, so how do you have credit? So we can't. And then you're like, well, how do I build credit if you won't give me credit, right? It's like when you go to apply for a job, they'll say experience needed. You're like, how do I get experience if you don't give me experience, right? It'll be like circular reasoning. That's what happens. All right. How we doing? I got to look in on these peeps. All right, good deal. Okay, so one of the ways that we can study these things, and this is often how science is done in general now, is it used to be that science was done in a manner where you had a scientist, either him or her, or a group of scientists maybe sat around and did experiments, right? And then they collected data. Hey, let's throw something in the air and see how long it takes to come down. Or let's roll balls down ramps. Or let's zap some substance with some other laser, or whatever. We just do experiments, and then we observe what happens, and we write things down, right? And then what we try to do is we try to make sense of that data. We try to come up with equations and to what we say model the data or explain it, predict. And luckily now there's this third component that is very, very useful, especially in prob and stats, and that is this computer component. Now, I'm not going to ask any of you to be computer whizzes in here, but I am going to use a computer from time to time to show you how we can study these kinds of questions by running what we call simulations. So for example, your guess on how many times I have to flip a coin until I get 5 heads, we can do that experiment in real life. I can say flip a coin, see how long it takes you to get 5 heads, right? Now we don't know, that could take 3 years for all we know. You don't want to spend your time doing that, do you? No. Or if I change the game slightly, I could say flip a coin 250 times. What's the longest run of heads you get? Maybe you get 12 heads at some point. Maybe you get 4. You don't want to flip a coin 250 times. But luckily, we have computers that can simulate that for us. We can make that experiment happen on a computer. So what I'd like to end with is a problem, and you can actually use this to make money with your friends. I used to do this. Someone taught me this when I was in high school, and I used to take money off people with it because it's a counterintuitive thing, but it works. So here's the last food for thought, a fun gambling problem. And then we're going to show how it's done on a computer, and it's likely going to sort of counteract your intuition. So here's a game. And this is the kind of problem that we want to be able to analyze fully by the end of the semester. Does that make sense? Like this is kind of like this problem, giving an answer to this is something that by December, you're capable of doing on your own. So here's a game. And this is sort of the essence of how a casino works. So you pay $1 to play. You have 3 options. Option 1. So option 1 says you roll at least 1 6 when rolling 6 dice. Option 2, you roll at least 2 6s when rolling 12 dice. Which game do you play? Which game has the better odds? So that is so let's rephrase this up here. Let's not say to play. Let's be more specific. You pay $1 to win $5. That's a good payout. You pay 1. If you lose, you're out $1. If you win, you get $5. Which game do you pay? 1 or 2? Just a reminder for those of you who are maybe not sure. Let's remind you what dice look like. So let me go to, let me change pages. So when I say dice, here's a pair of dice. There's 2. Let's imagine we're going to roll 6 of these. And let's just assume that each dice is labeled 1 through 6, and each outcome is just as likely, right? I mean, we can all imagine that's a fair scenario. Does anybody have a question about this? So let's go back. So what typically happens, by the way, let's play. What do you choose, 1 or 2? You ain't allowed to answer because you saw them. What would you choose, Tyler, 1 or 2? And why?
I'm gonna go with like the one. Trying to get in mind about the first one. I'm thinking like you have 1 in 6 chance at 6. So you put first roll of all 6. And the second one, you have to get 2 6s out of 12. So I was trying to do the math behind it.
All right, there is math behind it. And it's unless you have the right mathematical tools, it's not easy to do. So what you're thinking about, at least what I gather in your head, is you're trying to think of all the scenarios in your head.
1 in 6 chance the first one, the second one being like a 2 to 12.
That's correct, but that's for at least 1. But then remember, for option 2, I mean, so look, the reason this is sort of confusing, by the way, this is a famous problem from a couple hundred years ago. Newton from physics fame, like Newton's laws, if you're familiar with Newton, he's at least on record as the first one who solved this in a logically sound way. Turns out, if you give this option to people, most people will choose option 2 as a better. And the rationale is, since there's 12 dice, there's more chances for 6 to come up. That's the rationale, but it turns out that doesn't matter. Because even though there's 12 dice, that means there's more chances for 6s. That means there's more chances for not being 6s. So this is one of these issues where our intuition sometimes blinds us. Now, we don't correctly know how to finish. You're on the right track, and we'll learn something this semester that'll show us how to write up a solution in 2 lines. And now here's what's really, really cool. Instead of us being able to do that right now, I am going to go to the computer and I'm going to play this game 100,000 times. I'm going to play option 1 100,000 times. I'm going to play option 2 100,000 times. Now, it would take you a lifetime to play this game 100,000 times by yourself. And you would probably make an error because you'd be tired, and then you would probably write something down wrong, right? But the computer don't make those errors. So let's watch what happens. And by the way, if you ever want to learn how to do this, I'd be happy to show you how to do this. This is a cool thing. It's called Octave. It's a very useful piece of software. It's free. It's used by engineers and mathematicians and scientists all the time. So you don't have to pay much attention to all this. But if you're just curious, what I'm doing is I'm writing computer code to play this experiment over and over and over again. Okay, so what I'm going to do is I'm going to run it. Now, oh, I got to, hold on a second. I forgot to do something. I got to open the file or it won't work. Now we can run. Now, it's going to take a few seconds to run because that's what happens the first time you open it up. So right now, the computer's computing. It's doing an experiment. Right now, it's probably on like the 300th time. Now it's probably on the like 500,000th time. Now it's probably on the 600,000th game. Now it's on the 7th. You know, see, it's not instant, right? I hit enter. It's working. My computer, if you're up here, you feel it's hot. It's hot as hell because it's running. It's working. So one of the things all the data computer nerds, you know, they buy the gaming computers. Like you guys like, and I don't do it, but I know there's all these kids now. You guys like buy these fancy computers to play games, and then you videotape yourself and some other weirdos watch you play games, right? It's like how you're a Generation X. It's the strangest thing, right? This is true, right? I know this is what people do. Anyhow, the nerds buy those kinds of computers because their processing speed is so fast. So my computer's taking this good old time. It'll probably be another 15 or 20 seconds. There it is. So what I want to point your attention to, and let's see if I can annotate this. I think I can, is I ran this 100,000 times. So this number right here, that's how many times I did the experiment, 100,000 times. Now, what this number is right here, this number tells me the following. It says option 1 wins 60. It wins 66% of the time. What does option 2 win? Option 2, so game 2, the other game, it wins, at least this time, it won 62% of the time. So you are slightly more likely to win the first game than the second game. Does that make sense? And this is the process that casinos thrive off of, because your chances of losing aren't that small. Yet in the long run, you're going to lose. Now, by the way, for full clarity, this number right here, the 0.59, that's the game if you do 18 dice and ask to roll at least 3 sixes. So as the number of dice increase, your actually chances of winning decrease. Now, here's what's cool. These numbers below, this is the theoretical value. So we'll show you how to get this number. These numbers come from the math that you do by hand. We'll show you how to do that in a few, maybe in like 2 months, you'll know how to do that. But it's based off of what you were suggesting. You have to count all the scenarios, but you can't count them one by one because that'll take forever. You have to recognize patterns and you have to make sense. Any questions about this? And by the way, this thing that I did here, this quote unquote simulation, this is one of the ways that science and medicine really work now. I mean, imagine lots of things you want to study are too cost effective to do it or unsafe. You know, my area of research as a student when I was getting my PhD was neuroscience. I mean, people, you know, we're doing mathematics and neuroscience. I mean, how many people are going to go in there and let someone put all kinds of stuff in their brain and study their nerves? Not many people, right? Not only that, can you imagine the cost? So what we do is we simulate these experiments. Just like if I'm going to build airplanes, I'm not going to just build airplanes that cost $50 million a pop and test them. I'm going to build them on a computer and make simulated airplanes, see which ones are good, then go out and build them. So anyhow, if you ever want to learn about this stuff, I would encourage you to reach out. I'll give you opportunities for extra credit if you want to do it. It's not hard to learn this. It's real easy to have a computer flip a coin. You just ask it to give you a random number, either 1 or 2, and it'll generate a random number. If it's 1, heads. If it's 2, tails. Any questions? All right, well, listen, gang, I am going to end it here because that's the rules. We have to end. No, wait. No, we have to end in 15 minutes. I lied. That's good. We'll wrap up sooner than that. Does anybody have any questions about this? Go back to our whiteboard. Oh, you just ask them to bet, and they always choose option 2. And then you usually win. In the long run, you'll win. Yeah. I mean, that's the way things are. Like, if you study the mathematics behind like things like roulette, craps, it's real simple to, once you learn the math, you could see how casinos can get rich. It's called the law of large numbers. You always have these friends too. When you guys are old enough to go to the casino, which most of you probably aren't yet, you'll go and you always have these friends that say, I win all the time. No, they don't. Don't let anybody lie to you. Maybe at poker, but you have your own odds there. That's not the house. Anything where you're playing the house, they win. In the long run, of course. They even got you guys in there now with your mask on, pulling it off, smoking a cigarette, putting your social security check into the machine. Been to a casino yet? This is what it looks like. Everybody's smoking, wasting away their government cheese. All those old folks come in on like the big buses, and then social security checks are just, plowing into. Is what it is, man. All right. So this is the kind of problem that we want to be able to study. And these other problems too, like how many heads in a row do we expect to get, or how long do we expect something to take before something else happens? I mean, think about it. I mean, these things can be applied in real life scenarios all the time. You guys having fun yet? I'm not. Actually, this is okay. It's just not as fun that I can't gallivant around and I have you guys all look like we're in like some dystopian movie, but I guess it's not. It's reality now, right? Mask. Like my mask. I got it all for you guys that I got. Although someone told me Dr. Seuss was an asshole. Well, he's dead, so I might have to cancel him. Got my Wu-Tang on already. I love you guys. Platonically, of course. All right, let me check the chat. All right, so why don't we call today then, and then we will, again, you're going to get an email from me. Please set up your alerts on Canvas because everything's going to have to be done through Canvas. Even written assignments, you're going to have to learn how to copy and upload, or it's kind of hard to type math unless you know the proper software. So you're going to probably handwrite, copy, and scan or whatever. If you're not sure how to scan using your phone, it's free and easy now. So learn how to do it. Just Google your phone, scan. All right, guys, thank you very much. I will talk to you guys on Wednesday. Don't forget to email me if you want to talk about not coming or switching groups. I appreciate you guys understanding. Thank you very much, guys. Be safe.